All right, everybody, let's see here. This is the even test review questions. The octet rule, 8, states that chemical compounds, atoms tend to have their orbitals. They want, most atoms, like carbon, want to have 8 electrons in its outer shell, but unfortunately for carbon and most of the elements, they don't have a full 8. So they do not satisfy the octet rule. And atoms will give away, metals tend to throw away, nonmetals will take, nonmetals will even share their electrons to become stable. So they want to have 8 electrons, that's the magic number. The only exceptions are elements like helium that are so small they only need 2. All right, let's see, number 4. What is the formula for an ion formed when potassium, potassium, K, on the periodic table, achieves noble gas electron configuration? That means it either gains enough electrons to get 8, or since this is a metal, metals, it's easier for them to throw away electrons. Potassium looks like this guy, 1 valence electron, because it's in group 1 of the periodic table. So what it will do is it will throw that away, and it will become a potassium plus 1 ion, because that electron had a negative charge. At this point it was neutral, but when it threw away that electron, it became a positive ion. Number 6. All right, I already answered number 6 on the odd problem, so you can go watch the odd one for number 6. Number 8. How does calcium, that's Ca, obey the octet rule? That means it wants 8 electrons in its outer shell when reacting to form compounds. All right, calcium is in group 2. It's an alkali earth metal. Okay, how does calcium obey the octet rule? Well, calcium is in period 4, so its first shell has 2 electrons, its second shell has 8, its third shell is partially filled with 8, so its valence shell, these 2 right here, it throws those away. When it throws those away, its 3p sublevel is now full, and it thinks it is neon. So how does calcium obey the octet rule? It loses 2 electrons, and now it thinks it's neon, but it has, it thinks it's argon. My mistake. It thinks it's argon, but it has a plus 2 charge to it, because when it loses those 2 negative electrons, it becomes calcium 2+. If you were to do the electron, okay, here we go. Number 10. What formula will aluminum and oxygen ions form? Well, you're going to do crisscross. Let me zoom in. So I'm going to rewrite Al and O. We take that 2. Now we're going to have 2 aluminums. That plus 3 becomes the subscript there. So in these 5 molecules, we are going to have 2 aluminums. That'll bring a plus 6 charge. And 3 oxygens, bringing a negative 6 charge. And you altogether, you get this compound has no charge. It's neutral. And all of them have satisfied the octet rule if you were to do the Lewis structure for it. Which type of elements form ionic compounds? Metals bonded to nonmetals. That is an ionic compound. Molecular, covalent compounds are found in which states? Solids, liquids, and gases. Explain what causes this. Well, covalent compounds, covalent are the weaker bonds, unlike ionic, which has those electrostatic that we talked about here last time. So those bonds that are holding a covalent compound together aren't very strong, and because of that, it makes it real easy for it to either be a gas like air, or liquid like water, or a solid like ice or something. So it's just that the sharing electrons is a weaker bond, and it makes them more flexible, a little more movable, whereas the electrostatic, boom, they're locked together in a super tight pattern, because that's the strongest bond. All right, sorry, my cords are getting in the way. 16. How do atoms achieve noble gas electron configurations. Okay, that means they have 8 valence electrons, except for helium, which only have 2. So how do atoms get 8 electrons in their outer shell? Okay, the octet rule, in single covalent bonds. So, for example, probably the best single covalent bond we can think of is going to be chlorine. Can we make sure we're centered there? Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Another chlorine it'll team up with, having 7 valence electrons. Those two will share, and you get chlorine gas, Cl2. Now, if you cover up this guy, 8 electrons. They don't care that they're sharing 2. They got 8 electrons. 8 electrons. And the thing is now they're chemically attached. They're a true molecule, unlike an ionic compound, which is a metal and a nonmetal just being attracted to each other because they've gained or lost electrons. Number 18, draw the Lewis structures for these. Well, let's see here. It looks like I did some of these last night on the number 17 one. So, did that one. Let's see, oxygen. Okay, there's oxygen right there. Chlorine. Okay, you can come up and just look at what I just did there. I drew the for chlorine. Nitrogen, we drew it there. It's going to share those 3 pairs. Okay, now oxygen, the Lewis structure. So first off, oxygen, when you look on the periodic table to do its Lewis structure, oxygen has 6 valence electrons. So 6 valence electrons, but now we got to ask, it's an ion. Has it gained or lost 2 electrons? Well, it's a 2 negative ion. It had to gain 2 more negative electrons. So now we're going to do the Lewis structure like this. Now we got to say it's -2. It thinks, oops, put those square brackets. Oxygen now thinks it's neon, but it has that negative charge. Okay, N3 I did over there. You can watch yesterday's if you want to see me go through it. Calcium 2+ ion. Okay, calcium normally has 2 valence electrons because it's in group 2. Now it's a 2+ ion. It's a metal. Metals throw away their negative charges. So instead of putting the 2 dots, we're just going to put a little bracket around it, say it's got a +2 charge because its next lower energy level is now filled. And I think we actually talked about that a little bit. Yeah, I talked about that back at question 8. And carbon dioxide. Okay, now you got to decide what's the central atom. Carbon is. So carbon has 4 valence electrons. Oxygen has 6. 1, 2, 3, 4. And I'm going to put the 2 pairs over there. And what will happen is that will team up and that will team up and share. Now we got a double bond between this carbon and the oxygen. We need 1 more oxygen. 1, 2, 3, 4, 5, 6. Okay, those 2 will share and those 2. Now, this is kind of messy. In actuality, it'll be like this. There'll be a linear molecule. So if we asked you the shape for that one for Vesper, that's going to be linear. These guys were also linear, okay? So let's see. Now we're doing number 20. Which of the following formulas are are covalent? That means they're only nonmetals. Okay, there's a metal. That's ionic. That's a metal. It's ionic and a nonmetal. These are all nonmetals bonded together. That's covalent. Oh, sorry, I was going off the page there. All right, we got carbon and hydrogen. Those are both nonmetals. This is covalent. 22. What is the net charge on NaCl as an ionic compound? Okay, draw the Lewis structures. Na, sodium's in group 1, the periodic table. Chlorine is in group 17, or the old group 7. So 7 valence electrons. Sodium throws away its electron. It becomes Na+ ion. Chlorine takes that negative electron and puts it there, and it becomes chlorine -1 ion. I guess actually I should put all those dots around there. Altogether, this whole compound is neutral. The plus charge and the minus charge. Sodium's next lower energy level is now totally full. It has 8 electrons. They both think they're noble gases, but they're stuck together. That's the price they pay. Number 24, what happens with electrons in an ionic bond? The metals, like sodium, throw them away. They get rid of them. Metals lose electrons. And nonmetals, like fluorine, they need electrons, so metals lose them. Nonmetals, like fluorine, they gain. They gain those electrons. So it's a perfect relationship. The metals love to get rid of their electrons to become like a noble gas. Fluorine loves, nonmetals like to take them so they can become like a noble gas. It's a whole bunch of envy. Most atoms want to be like the noble gases. 26, what is the chemical formula when calcium bonds with oxygen? Calcium is a metal, Ca. I'm going to just do its Lewis structure because when in doubt, do its Lewis structure. Oxygen is a nonmetal, so that's going to be, when a metal bonds with a nonmetal, that's going to be ionic. Now let me see here. I'm going to do 1, 2, 3, 4, 5, 6. It looks like to me calcium's going to throw away that electron and like that, and you're going to end up with calcium plus 2 bonded to an oxygen with a minus 2, and altogether you get calcium oxide. You get a stable compound. 28. When hydrogen forms a bond with a halogen. Okay, here's hydrogen. I'm going to look on the periodic table. The first halogen I see at the top is fluorine, okay? What type of covalent bond is formed? Polar or nonpolar? All right, so hydrogen, that's where you got to see its electronegativity is 2.1, because this is how we're going to tell whether this is polar. Now, in our reading passage, this was a penguin. That's a polar bear. This is going to be a ionic polar compound. But they're both nonmetals, so they can't be ionic. Fluorine's electronegativity is 4. So we're going to do 4 minus 2.1. I think that comes out to be 1.9. Wait, make sure. Yeah, 1.9. And we look on our chart. 1.9 is very covalent. In fact, that's the example we got right there on our chart. That means that you are going to have that when these two share, actually hydrogen almost gives its electron, almost. So this is going to become partially positive because it's just got its proton sticking out. This one will be partially negative. This will be polar. That means it's got a plus and a minus side, or at least a partial plus and a partial minus. So you'll use the chart there to do that. What is the electron configuration of nitrogen? Electron configurations, you need to take a look at, use the slanted diagram. You need the total number of electrons. Nitrogen has 7 electrons. So for nitrogen, this is going to our packet here. We need 7 electrons. So let's see, we're going to have 1, 2, 3, 4, 5, 6, 7. 1s2, 2s2, 2p3. 1s2, 2s2, sorry, 2p3. All right, sodium has a total of 11 electrons, okay? So we're just going to keep this up. 1, 2, make sure you can see that on there. We need 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's going to be 1s, 1s2, 2s2. Let me make sure we can see all of those. Okay, and then we got the 2p with 6, 2p6, and 3s1. If we've done it right, those should all add up to 4 plus 6 to 11. Silicon has 14 electrons. So here was 11, 12, 13, 14. So silicon, let me zoom. You can see all of this. Come over there. So for silicon, we're going to be 1s2, 2s2, 2p6, 2p6. Let me erase that old 3 from our previous problem. 3s2, and then 2p4. And you add those all up, it should be 14. Okay, chlorine has on the periodic table 17. So it's got 3 more electrons than silicon had. So I'm just going to come up here. 1, 2, 3 more electrons than silicon had. Oh, we don't need that. So to fill that in, we're going to have 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4, 5. All the halogens end in a P5 sublevel. And you might see on the test, they might do this one and they might say, hey, for chlorine, they might write it as neon, 2, 4, 6, 8, 10, and then put 3s2, 3p5. That's another way that the electron configuration for chlorine could be written. All right, let's see. Number 32, I answered yes on the other on the odd question sheet, so you can go see that. 34, the electron configuration of O-2. Oxygen normally has 8 electrons. This is an ion. It's gained 2 electrons. So we need to do the electron configuration basically for neon, which is going to be 2, 4, 6, 8, 10. 10 electrons. It's going to be 1s2, 2s2, 1s2, 2s2, and 2p6, which would be the same electron configuration as the nearest noble gas. Magnesium 2+. Okay, magnesium normally has 12 electrons. It's a 2+ ion. It's lost 2 electrons. Minus 2 electrons equals 10 electrons. Its electron configuration is identical to that because it loses electrons to be like neon. Okay, 36. How many electron shell? Okay, lithium is in period 2, so it has 2 shells. Calcium is in period 4, so it has 4 shells. Sulfur is in period 3, 3 shells. Chlorine, 3 shells. Period 3, and argon, period 3. So all of those elements there, except for, so these guys, that tells you how many shells they're going to have. If we were kind of going with the old Bohr model. Oh, that should have been 3, not 4. Okay, valence electrons. Lithium is in group 1. Calcium is in group 2. Sulfur is in group 16. So we're just going to ignore that. 6 valence electrons for sulfur. And chlorine is a halogen. It's got 7 valence electrons. It's in group 17, but we just focus on the 7. Argon is a noble gas, group 18. All noble gases have 18 except for helium, which only needs 2. Almost done here. My wife's in the parking lot waiting for me. I am in such big trouble. Where are the following groups on the period? Okay, you just get those labeled. Alkali metals, alkali earth metals are there, transition metals are there, halogens are group 17, noble gases are over there. And remember, all of the alkali metals, their electron configurations end in an S, as an S1. This would be 4s1, so on. All of the alkaline earth metals, their electron configurations end as an S2. This would be 2s2, 3s2, 2s2, 4s2, so on. All of the noble gases are going to end, all of the transition metals are going to end in a D. All of these over here in the D block, they're going to end in a P designation. And for these, the halogens, it would always be a P7. P, sorry, too many. I gave it too many. P, my brain's going out. P5. And these would always be, the noble gases, a P6 designation. That'll come up. All right, draw the Vesper model for CO2. Well, we've drawn CO2 previously, and we know CO2 is going to look like this. And it turns out, if you were to subtract carbon and oxygen, you're going to find out that it's nonpolar, it's straight line. This is linear. CH4, we worked on this in class, okay? It's going to end up looking like this. Now remember, each of these lines I'm drawing represents a pair of electrons being shared. Now, for methane, what's going to happen is 2 of those are probably going to be coming up, are going to be going away from us, so we tend to try to draw that this one's going down, that one's going away from us, and then if that's the case, oh, I drew this backwards. Okay, this will be coming up towards us, sticking up out of the paper, So these guys are coming up towards us out of the paper. These two would be going down. This is going to be tetrahedral. This is going to be one of those where it'd kind of look something like that. We had that class. That's a three-sided. That's supposed to be a three-sided. Three-sided pyramid. Nitrogen. So when we drew the nitrogen previously, nitrogen ends up like this. Okay, it's going to have a triple bond right here, and so it's in a straight line. It's linear. PCl3. Okay, phosphorus is in group. It's like nitrogen in that it's got this electron configuration. So what's going to happen is you're going to get a chlorine attached over here, and another chlorine, and another chlorine. So what happens is we've got these guys down, and they're actually going to end up, it's going to be the triagonal pyramidal, because this pair of electrons, they're kind of spinning right there. They're not really forming a compound. So this one, chlorine, would be coming out towards us. Oh, sorry. Let's say it's going to be going down from us, chlorine. Okay, this chlorine over here will also be going down away from us. Kind of imagine that the phosphorus is going to be up here on the paper, and that chlorine over there is going to be going down. It's kind of like a little rocket ship with the landing gear down. Phosphorus will be right here, and then right at the very top will be a little spinning pair of electrons. They don't give it towards its shape. So this is triagonal, and it's a pyramid shape. So it would kind of be like this. I was trying to draw it earlier. Kind of like that, okay? So we've got a pyramid shape there. Oh, wait, I'm kind of wrong there, but my problem is I made a tetrahedral there. We've got these 3 points at the bottom, okay, and then this part right there is just slightly above over here, so it's very slightly elevated. So this one would be triagonal, pyramidal, compared to this guy, which was a tetrahedron. Because this one actually has an atom up there. It's one of those. There's an atom over there, an atom over there. It's got an atom over there. So it's got 1, 2, 3, 4 atoms on the outside, and then you got carbon in the middle. This guy has only 3 atoms here, and then you got phosphorus in the middle. It doesn't have a guy sticking up here. So they call that triagonal pyramid. It's not a full tetrahedron. That's it. I'm done.